In this video, we're going to do a few examples of factoring trinomials that have a leading coefficient of 1, but that also have a GCF. So here we're asked to factor the polynomial 3z squared minus 15tz plus 12t squared. Now this example looks a little bit different than the ones we've done so far, but I argue that if we just follow the process that we know, that this should work out in the end. So let's just follow the process that we know for factoring a trinomial and see where this goes. The first step to factoring any polynomial is to look for a GCF. 3, 15, and 12. The largest number that will evenly divide all three of those is 3. So we know 3 will be the coefficient of our GCF. Then we look at the variable portion, z squared, tz, and t squared. And we find that neither of these three terms have a variable factor in common. So there is no variable factor of our GCF, and our GCF is just 3. So let's factor out the GCF and divide each term in the original polynomial by 3. 3z squared when divided by 3 leaves us with z squared. Minus 15tz when divided by 3 leaves us with minus 5tz. And 12t squared when divided by 3 leaves us with 4t squared. Now let's look at the polynomial we have remaining inside our parentheses. That's a 3-term polynomial with a leading coefficient of 1. So this is a trinomial with a leading coefficient of 1. So let's continue factoring that trinomial. We know that the trinomial will factor into 2 binomials. And we also know that we need to bring our GCF down with every factoring step that we take. All right, to get the first term in each binomial factor, here and here, when we multiply those 2 terms together, we know that we must get a z squared. So there's no other option but z and z. Now let's look at the last term in our polynomial, 4t squared. We know that when we multiply this term by this term, that we have to get 4t squared. That means that each of these terms must contain a factor of t, because t times t gives us t squared. But we also must come up with 2 numbers that when multiplied give us 4, but when added give us negative 5. 1 times 4 is 4, but negative 1 times negative 4 is also 4. Or we could say that negative 2 times negative 2 also gives us a positive 4, and that 2 times 2 also gives us a positive 4. So those are all the different combinations of 2 numbers that when we multiply them together give us a positive 4. Now let's change all of the multiplies to adds, because the 2 numbers that we choose have to add to give us negative 5. 1 plus 4 is positive 5. That's close, but that won't work. Negative 1 plus negative 4, well, that's just negative 1 minus 4. Well, that is negative 5. So there's the correct combination. Negative 1 times negative 4 gives us positive 4, and negative 1 plus negative 4 gives us negative 5. So then the correct coefficients to go in front of our variable t are negative 1 and negative 4. Now you may say, well, we took careful measures to make sure that we got a 4 as our coefficient of our last term, and that we got a t squared as the variable portion of our last term, and that we got a negative 5 as the coefficient of our middle term, but we really didn't take very much care in making sure that we got a tz combination in the middle. Well, let's just FOIL this thing back out to make sure that the tz portion worked out okay for us and that this is definitely the correct factorization. When we FOIL this factorization back out, we get z times c, which is z squared. And of course, I'm going to bring down my GCF. Z times negative 4t is negative 4tz. Negative t times z is negative tz. And negative t times negative 4 is positive 4t squared. Now let's combine our like terms. In the middle, we'll have negative 4tz and minus 1tz, which is minus 5tz's plus 4t squared. And now let's distribute the 3 to each one of our terms to make sure that we get the exact expression that we started with. 3 times z squared is 3z squared, minus 5tz times 3 is minus 15tz, plus 4t squared times 3 is plus 12t squared. And that is indeed what we started with, so our factorization must be correct. Let's take a look at this example. Here we're asked to factor negative 3ax squared plus 9a minus 6ax. The first step to factoring is to look for a GCF. Our leading coefficient is negative, and the largest number that will evenly divide 3, 9, and 6 is 3. And then when we look at our variable portions, we have ax squared, a, and ax. Each one of those terms has an a in common. So our GCF is negative 3a. So let's divide out our GCF and divide each of the original 3 terms by the GCF. Negative 3ax squared divided by negative 3a leaves us with just x squared. 9a divided by negative 3a leaves us with negative 3. And negative 6ax when divided by negative 3a leaves us with 2x. We'll continue the factoring process by bringing down our GCF. And when I look at the trinomial here that I need to continue factoring, I notice that it's not written in descending order. Anytime we're factoring, we need to always write our expressions that we're factoring in descending order. So let's rewrite this trinomial in the correct descending order. That'll be x squared plus 2x minus 3. Now we're in the correct form and we can continue factoring. Well, this is a trinomial with a leading coefficient of 1, and trinomials with leading coefficients of 1 are going to factor into 2 binomials. To get an x squared, we must have an x. So the first term will be x and x. Then we need 2 numbers that when multiplied give us a negative 3, but when added give us a positive 2. Well, those 2 numbers are positive 3 and minus 1, because 3 times negative 1 gives us negative 3, and 3 minus 1 gives us 2. So there's the correct factorization of our original polynomial. All right, let's factor this polynomial, 3x plus 6x squared plus 3x cubed. Well, right off the bat, it's really easy to tell in this example that this polynomial is not written in descending order. So let's first write it in descending order before we even attempt to factor it. All right, perfect. Now we're in descending order. Now the first step is to look for a GCF. The biggest number that will evenly divide 3 and 6 and 3 obviously is 3. And then the largest variable factor that will evenly divide x cubed, x squared, and x is x. So our GCF is 3x, and we're going to factor that out by dividing each of our original 3 terms by the GCF of 3x. 3x cubed divided by 3x leaves us with x squared. 6x squared divided by 3x leaves us with 2x. And 3x divided by 3x leaves us with 1. Continue factoring the trinomial with a leading coefficient of 1. Bring down the GCF. We know that that trinomial will factor into 2 binomials. To get the x squared. We must have an x and an x as our first terms in our binomial factors. Now we need two numbers that multiply to give us 1, but add to give us 2. Well, those two numbers are 1 and 1, because 1 times 1 is 1 and 1 plus 1 is 2. So the factorization of this polynomial is 3x times x plus 1 times x plus 1. Or another way to write that is 3x times x plus 1 squared.